the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcome.
Hello, my name is Roy Simpson, professor of mathematics at Cosumnes River College in Sacramento, California. This video is dedicated to linear algebra students who have already gone through a review of systems of equations, row reduction and echelon forms, vector equations, and matrix equations, not actually dealing with the arithmetic of matrices or working with matrices very intensely, but at least just working with matrix equations. Now we're going to delve into solution sets of linear systems. And before we can do that, we need to introduce a very special kind of linear system, and that is the homogeneous linear system. A system of linear equations is said to be homogeneous if it can be written in the form AX equals 0, where A is an m by n matrix and 0 is a zero vector in Rm. Now, you may think, well, that's a pretty quick definition. Why'd you make a full video for it? It is because it turns out that homogeneous linear systems are incredibly important in linear algebra. So for an example, just to show you the impact of this, you could probably agree with me that the right-hand side of each of these equations is non-zero. So when I write this as a matrix equation, I hope you would agree that this matrix equation does not have a zero right-hand side. That is, this is not a homogeneous linear system. In fact, what we would say is this is non-homogeneous, and it is because it's not homogeneous. Versus if somebody handed us this system, we should easily be able to tell that written as a matrix equation, this is a homogeneous linear system because it can be written as AX equals 0. Now remember, the other one, system that is, can be written as AX equals B. Something that we'll learn in the future though, is that when you're trying to solve a non-homogeneous linear system through its matrix equation, you will often end up solving the non-homogeneous system as well. And that is because the solutions to the homogeneous system are part of the solution to the non-homogeneous system. For an example, if I told you that the vector C solved this system, let's just pretend for a moment. Now, I'm introducing a concept that'll appear in the future, but I want you to see, because this is such a short definition, that I want you to see the impact of it. If I told you that the vector C solved this equation, and if I told you that the vector D solved this equation, then I promise you a bigger solution to this system right here is not just C, it's C plus D. How do I know that? The matrix A times the sum of the vectors C and D. Well, we have a theorem, and that theorem is on our list of very important theorems, and the theorem is what I would call theorem 5, part A, which is that a matrix A times the sum of vectors is just the matrix A times the first vector plus the matrix A times the second vector. So going back here, this matrix A times C plus D is actually the matrix A times the vector C plus the matrix A times the vector D. But remember, we're pretending as though A times C is actually B, and we're pretending as though A times D is equal to 0, and the vector B plus 0 is just the vector B. So not only is C a solution to AX equals B, so is C plus D, because A times C plus D is also equal to B. So this is kind of a very important point to make. Homogeneous linear systems are critical for your success in linear algebra because the solutions to them end up being part of the solutions to non-homogeneous systems. Now that's it for this video, very short video, but I just want to sneak this in here with a little bit of extra theory there. So I hope this is helpful for you, and I hope to see you in future videos. Have a great day.
It's the system of equations. We must deal with them all at once. Always looking for solutions. our way, cause affects more than we can sometimes see. Things for what they are and work together until you feel at peace. Says, listen close, don't talk too much that isn't cold. Sure, you may really hurt inside. It doesn't justify you to speak too loud and cry.